let's get started, students. Using E0 values to predict cell voltages. So we are going to connect two of the cells together without connecting them to standard hydrogen electrode, then calculating that what would happen to those cells. Now take a look. In this example, we are connecting a silver ion half cell to a zinc ion half cell. And we know their values from separate connections. When they were connected to She, their values were this. Now, what would be the voltage of this cell? That would be the voltage of cell. This would be 0.80 minus 0.76 plus 1.56 volts. In order to get that, there is a simplest way of way to understand this. It is calculated in the cell voltage in which we always subtract the less positive E0 value from the more positive E0 value. So the more positive in this case is 0.80. And from that value, we'll subtract minus the less positive value, that is minus 0.76. Hence, we'll get the voltage of the entire cell. That means you can calculate the voltage from just two given equations in this standard E0 values, E standard values. Are we clear about this?
Yes.
That's very easy. Let's go with another example. Instead of repeating the same example, let's go with another one. Let's go with its diagram first, actually. Take a look. This is the silver part of the cell with the silver rod and silver solution, 1 mole per decimeter cube. And this is the zinc part of the cell, zinc rod and zinc solution. Okay? They're connected with a voltmeter and the salt bridge. This voltmeter shows 1.56 volts. But before we do that, theoretically speaking, how do we calculate 1.56 volts from these two values? One of them is 0.80 volts positive silver cell when we connected it to She, and one of them is the zinc one. When we connected it to She, we got the value minus 0.76 volts. So these two values, when combined together, is combined in such a way that the more positive value is written first, then comes the minus sign, then the less positive value or the negative value, and we get the mathematical total to be 1.56 volts. This is the theoretical working way. And this theoretical working way can actually be confirmed from the voltmeter in the experimental form as well, which also says 1.56 volts. Do we get the idea? Josema, are we clear? All right, let's take a look. What we do is that we calculate it from E0 values that silver lies on plus 0.80 volts on this whole line. Okay? And zinc lies all the way to the bottom to minus 0.76 volts. And when they are calculated in terms of difference, the difference is 1.56 volts. We can also calculate it by the usage of mathematical lines, right? Or it can easily be done on a calculator. The E0 values of silver half cell.
से अगर जितना ज्यादा वोल्टेज होगा उतना ज्यादा आसान होगा पूरा प्रोसेस हमारे पास।
किसका वोल्टेज ज्यादा होगा, सेल का या इंडिविजुअल हाफ सेल का?
इंडिविजुअल हाफ सेल का।
मतलब मैं समझा नहीं, उससे कैसे आसान हो सकता है? Because it depends upon both of the values, not just one value.
सर अगर फॉर एग्जांपल एक मेटल है उसका वो +1 है, दूसरे का -1 है, E0 वैल्यू दोनों की, तो ज्यादा एफिशिएंट होगा।
अच्छा बेटा, इस तरह से सेल की एफिशिएंसी तो नहीं निकाली जा सकती, लेकिन इस तरह से सेल की वोल्टेज वैल्यू जरूर कैलकुलेट की जा सकती है। ठीक है, whether it will produce a higher voltage or a lower voltage. So हाँ, उसकी नेगेटिव में वैल्यू भी बड़ी हो, उसकी पॉजिटिव में वैल्यू भी बड़ी हो, तो सेल की वोल्टेज ज्यादा होती है। ठीक है, and vice versa will have a smaller voltage value. But as far as the efficiency is concerned, there are many things: the working of cells, the structure of cells, the equations or the elements used, all of these come to play. ठीक है, तो मैं सिर्फ एक चीज से कि हमने सिर्फ सिल्वर और जिंक यूज किया तो सेल बड़ा एफिशिएंट होगा, इस बेसिस पर डिसाइड नहीं कर सकते, बिकॉज देयर आर मेनी फैक्टर्स दैट आर प्लेइंग देयर पार्ट। ठीक है, सेल की वर्किंग, सेल की फॉर्मेशन, सेल के कंस्ट्रक्शन, सेल के जो पार्ट्स होते हैं किस तरह से अरेंज किए हुए हैं, दैट ऑन दैट डिपेंड्स अ लॉट द एफिशिएंसी ऑफ द सेल इटसेल्फ। ठीक, Are we clear, Khuzaima?
Yes, sir.
Okay, moving on, the E naught value for silver ion silver half cell is more positive than for the zinc one. So silver is the positive pole and zinc is the negative pole of the cell, as given in the diagram as well. Okay. From electrochemical cells such as iron ion, iron plus 3 ions, and iron plus 2 ions, and a copper cell, one of them is an ion based system, and one of them is a metal and metal ions based system. When they are connected together, the overall voltage of the cell is plus 0.43 volts. How do we do that? The larger positive value is written first, then comes a minus sign, and then the smaller positive value, okay, and we get the voltage of the cell, right? In this case, iron has a larger positive value, so this is the positive pole, and copper having the smaller positive value will be the negative pole. This is the diagram that explains it. Copper rod, copper solution, iron in terms of platinum, and with both the solutions of iron 3 and iron 2. Do we understand this one as well? So that concludes our work for today, I guess. Just a second. Just a second, Vida. Okay, any more questions before I wind up the class?
Nice.
Okay. Thank you, class. That would be all. Allah Hafiz.
Good.